All right, so our last section is on tolerance. The idea here is that if you are going to buy a box of cereal, most likely you're not going to get the exact amount that they say is in there. So if they say that it's 30 ounces, the probability that you get 30 ounces exactly is, you're not always going to get the exact answer, okay? So there is some tolerance, like maybe it can be above or below that by like 0.4 ounces. The distributor decides, or the person that's making it is deciding how much they're okay with that it's basically 30 ounces, okay? So it's close enough. So they decide what their allowable error is, okay? So our tolerance, we have two different situations. We have what is acceptable inside the boundaries. So if we think about an and, remember that this is and that means between, okay? When it's inside the boundaries, we're taking the actual value. Your x is always going to be an x, so whatever the actual value is minus your ideal, that's the center, or your average, okay? And then less than or equal to the tolerance. So how much it can be above or below. That's the distance from the center. And then if it's something not acceptable or outside the boundaries, okay, think about an or situation, and that's a greater than sign. So it's going to be on the outsides of two values. And it's the same setup, actual minus ideal, but now it's greater than the tolerance. So let's look at an example. So a 16-ounce bag of flour probably does not weigh exactly 16 ounces. Suppose the actual weight can be between 15.6 and 16.4 ounces, inclusive. Write an absolute value inequality that describes the acceptable weights for a 16-ounce bag of flour. So first thing we have to look at is, are we going to be finding an and or an or situation? So it asks for what are the acceptable weights. So if we look back at what I was talking about in the last one, acceptable means and, between. So we want to know between what weights is it acceptable. So that tells me that it's an and situation. Okay, so in my answer, I'm going to have x minus something less than or equal to something. Okay, so this number is my ideal. Okay, in this case, I want it to be 16 ounces. That's the ideal weight. So 16 goes there. Now, it says it can be between these two values, okay? If I take 16 minus 15.6, I'm going to get 0.4. Same thing if I take 16.4 minus 16. That means it can be above 16 by 0.4, and it can be below 16 by 0.4. So that is my tolerance. And that goes on that other side of the inequality. So this is my answer. So let's make sure that that's what we wanted. So if I were to solve this like in our last section, I would have it set up like this. Okay, and then I'd add 16. So that would give me 15.6 less than x less than or equal to 16.4, which is what I wanted. That's what that's describing. So that means I set up the inequality correctly. So this is my answer. This is just to check myself down here. This is my check. Okay, let's try another one. The length of a basketball court can vary from 84 to 94 feet inclusive. Write an absolute value inequality that describes the possible lengths. So I would pause, think about it for a little bit, try it. So we want to write one that describes the possible length. So that's acceptable. So that means it's an and. So my answer is going to be an absolute value, and I'm going to have a less than or equal to. Now it says it can be between 84 and 94. So that's what's okay. So I need to figure out what the middle of that is, the ideal. So that's the average. So 84 plus 94 divided by 2. This is my ideal. That's what I'm looking for here. And when I divide by 2, I'm going to get 89. So my ideal, my center, goes right there. That's my center. Okay. So 89 is the middle, and then I need to see how much above and below it can vary. So I just take 94 minus 89. That's 5. So my tolerance is 5. So this is my answer. Okay? Because I can be above or below the 89 by 5 feet. Okay? Here's our last example. The table gives the recommended weight ranges for the balls from 3 different sports. Write an absolute value inequality describing the weights of the balls that are outside the recommended range. So now it's asking for the weights of the balls outside the recommended range. So that means I'm in an or situation. It says outside. So what I would suggest that you do is try this on your own first. Okay? So for volleyball, we have 260 to 280 grams. So we want it to be an absolute value where it's x minus something, and we want it to be outside something. Okay? So we need to find the average. So 260 plus 280 divided by 2. That's 270. So 270 is my center. Goes in the center. And then 260 and 280 are above and below 270 by 10. So that's my absolute value inequality. Okay, try your other ones. And you're going to do the same exact process, and you will get these answers. By doing that same thing each time. Okay, give your homework a shot and let me know if you have any questions.